Okie dokie. So, first off, have we ever graphed quadratics like this? Think about it. Is this the form in which we've graphed it? So far, what we've seen is f of x equals ax squared plus bx plus c, right? And we've said, hey, if we have f of x and we don't have that bx, we have ax squared plus c. There's a lot of things that we know from this, right? We know the a tells me whether it's getting wider or steeper. We know the c tells me how much it moves, yeah? Up and down. Okay, this doesn't look like that, correct? Okay, that's first. Do we agree? Why are y'all being so quiet today? I could use a little interaction. Just give me a little bit. So when I substitute in 5, my first thing is 5 minus 3 in parentheses, which is 2. 2 squared is 4. So my first ordered pair is 5 comma 4. And there's a reason why I've used these numbers. 4 goes in. 4 minus 3 is 1. 1 squared is 1. So that gives me 4 comma 1. 3 minus 3 is 0. 0 squared is 0. So that's 3 comma 0. 2 minus 3 is negative 1. But wait, negative 1 squared is positive 1. 1 minus 3 is negative 2. Negative 2 squared is positive 4. Okay, so before we graph, what are some things that you notice about this? What are some things that you notice about our numbers? This is where you're going, this is a give and take now. What are some things that you notice about some of our numbers here?
The y's go from 4, 1, 0, 1, 4.
Okay, so what does that mean? Like, yes, they do that. You've read them, but what are you seeing?
Pattern.
Oh, you're seeing a pattern. So, here's 0. These two are the same. These two are the same. Remember, in quadratics, one side has to have the same exact y values as the other side. Our x's are going to be different, but one side is going to be the exact same as the other side. That's how we get that nice U shape. Somebody's messaging me. I'm trying to schedule your surgery. I don't want to talk about my surgery right now. Hold on. Okay. I'm all right. I'm happy. It's fine. So we're going to graph. So we're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is all in the first quadrant because all of my x's are positive. Everybody agree? So 5 comma 4. 5 up 4. 4 up 1. 3, 0. 2 up 1. 1 up 4. Okay. Everybody with me still? Here's what I want to know. What do we know about this? Based off of the quiz, look at some of the questions on the quiz. Okay, so if you saw your quiz out, what are some things that we absolutely know from this graph that we've now graphed? Go ahead.
The axis of symmetry is
Ooh.
3 over, not 3 over 3, 0.
The axis of symmetry is x equals 3. So that's perfect. That means this side, if we fold it, it's exactly the same. That's so far so good. Okay. What else do we know? What else do we know?
It's a minimum.
Huh?
Minimum.
I couldn't hear you, Lydia. I'm stuffed up. Say it again.
It's a minimum.
It's a minimum. What's the minimum?
3. Wait, what?
What is that ordered pair?
Oh, 0, 3. What? No, 3, 0.
3, 0. Our minimum or maximum are also always the what? It starts with the V. The vertex. So we know the vertex is 3, 0. Okay. These are the two main things that we need, the axis of symmetry and the vertex. So now let's look at that equation. So we had f of x equals x minus 3 squared. Our axis of symmetry was x equals positive 3, and the vertex was 3, 0. Okay, I want you to kind of just, I'm really focusing on our equation was x minus 3 squared, but our axis of symmetry was x equals 3. The vertex was positive 3, 0. Well, let's go to the next one. Let's see if we can see a pattern going on here. -1 minus 1 is -2. Squared is 4. 4 plus 2 is 6. Everybody with me? When we square something, it is positive. 0 minus 1 is -1. Squared is 1. 1 plus 2 is 3. So I have -1, 6, 0, 3. 1 minus 1 is 0. 0. 0 plus 2 is 2. Gives me 1, 2. 2 minus 1 is 1. 1 squared is 1 plus 2 is 3. 3 minus 1 is 2. 2 squared is 4 plus 2 is 6. Okay, so one more time I'm going to ask. What do we see here? What are we seeing when we look at this? Patrick gave us it in the first one.
The 3's are the same.
The 3's the same. The what else's are the same? The 6's. There's a pattern. Notice how there's a number that doesn't match up with anything, and then when we go one out, it matches. When we go one out, it matches because they are, what S word am I going to use? They're symmetric, which means each side is exactly the same. So, let's graph this one. -1, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, here we go. -1 up 6. So far, so good. 0 up 3. 1 up 2. 2 up 3. 3 up 6. Well, that's not quite 6, but there you go. Okay, there we go again. Give me some things that we know. Give me some things that we know about this. Just the two things that we've just already talked about. Because this is going to be important.
Axis of symmetry is x equals 1.
What?
X equals 1.
The axis of symmetry, which I call the AOS, is x equals 1.
Vertex is 1, 2.
What's funny? What's so funny? What did I do? Okay. So the axis of symmetry is x equals 1. And then what is our vertex?
1 and 2.
What is it?
1, 2.
The vertex is 1, 2.
We're done.
Okay. So let's look at that equation again. So our equation is x minus 1 squared plus a 2. But our axis of symmetry is positive 1, and our vertex is positive 1, 2. Is there similarities between our first warm-up problem and our second warm-up problem as far as the axis of symmetry and the vertex? Are there similarities? Where are we getting the axis of symmetry from the equation? Where do you think we get that axis of symmetry from the equation? So the axis of symmetry in the first one is x equals 3. Can we see a positive 3? In the equation? Do we see a positive 3 in the equation? No, what do we see? A negative 3. Where?
In
In the what?
parentheses.
In the parentheses. Ooh, okay. The axis of symmetry in the second one is x equals positive 1. Do we see a positive 1 in the equation? No, but do we see a 1 somewhere? Where is it?
Parentheses.
Oh, so wait a minute. And what I hear you say is you're seeing this 3 in the parentheses, but it's the opposite. So our axis of symmetry is the opposite of whatever's in the parentheses? The axis of symmetry is the opposite of whatever's in that parenthesis. What about our vertex? Our vertex is also the opposite of whatever's in that parenthesis, but where did I get 0? So the vertex is the opposite of that, but then a 2. Hey, wait a minute. There's a plus 2 here. Is there anything over here? No. So really, this could be a plus 0, because I can add 0 to anything. Oh, wait a minute. So the opposite, and oh. So what all of this was to do was to show you what's called vertex form. Okay? So go ahead and get your notes out. Where's my brag? I don't even know what time we're done today. We're done at 9:50. Oh man. Okay. We're gonna have a very short lesson today. We'll pick it up tomorrow. Okay, so we are talking about quadratics in vertex form. Vertex form is f of x equals x minus h squared plus k. It's really a, let me do this correctly, a times x minus h squared plus k. The axis of symmetry is always x equals h. The vertex is always h comma k. I want to make sure that I'm doing this right. Yay. This is the lesson for now. Okay? We will talk about this more tomorrow because I absolutely do not have enough time in 5 minutes to go over everything. But you want to absolutely have this big bold somewhere that the vertex form is a times h minus x minus h squared plus k. The axis of symmetry is x equals h. The vertex is h comma k. And I will explain all of that tomorrow. What questions do we have? Okay. No homework today. Love y'all.